Good afternoon, dear participants, and good afternoon, Dr. Prashant Kumar Bhuya, who is our today's resource person. Also, I welcome my colleagues and my friends, Mr. Sitashu Kumar Das. He is the assistant professor at GC Keonjhar. Now, I would like to request Mr. Sitashu Kumar Das to introduce Dr. Prashant Kumar Bhuya, sir. Now it is handed over to Mr. Sitamsu. Please, Sitamsu. Carry.
Thank you, sir. A very warm welcome to all the participants to this online webinar. Good afternoon, all. Respected Professor Prashant Kumar Bhunya, sir, and Professor Sujit Pradhan, sir, from IGIT Sarang, and dear participants, we are extremely fortunate to have Professor Prashant Kumar Bhunya, sir, for our webinar. We are extremely thankful to him, sir. Sir has completed PhD from IIT Bombay and MTech from IIT Roorkee, and now continuing as assistant professor at NIT Rourkela, Odisha since 2011. He has guided many number of MTech and PhD students and more than 50 publications in various reputed journals like ASC and others. His area of interest is traffic engineering and transportation planning. On behalf of organizing team, I welcome you, sir, to this webinar to deliver your lecture, and I hope participants will be having a great conversation with you. And thank you, sir, and over to you, sir.
Okay, now I would like to request Dr. Prashant Kumar Bhuya sir to present on modeling service quality of urban street facilities using statistical and AI methods. And welcome, sir. Welcome to ARC 2021 IJT Saran. Now you may continue, sir.
Thank you, Sujit and Sitanshu for introducing me and giving this opportunity to present this topic on modeling service quality of urban street facilities using statistical and AI methods. So before going to much depth into the subject, this is purely research-oriented topic, and this topic on which one of my PhD student, Dr. Sambit Beura, he completed PhD under my guidance at NIT Rourkela, and he has done wonderful job and published more than 10 papers, journal papers, and so many conference papers. And this topic, which is a very much valuable topic, I find all of you know that on our roads, we have non-motorized mode of transportation as well as motorized mode of transportation. Under non-motorized mode of transportation, again, we have pedestrian mode and we have bicycle mode and a few other modes. So these non-motorized modes are always the neglected one. We are reluctant to provide their due space. That's why the kind of service quality they should get gradually or over time period that is deteriorating or decreasing. So we should know what kind of service quality these non-motorized modes, particularly bicycle mode that I am going to discuss, are getting at present. And if you will not do anything, then the service quality, of course, will go on further deterioration or deteriorating. And so we should do some kind of mathematical exercise or mathematical modeling for which we have to do much in-depth study regarding the dependent variable, the independent variable, and of course application of these techniques broadly classified as statistical techniques and some of the AI techniques. Beyond that, we will also discuss something on motorized mode of transportation, service quality. So these two things are very interesting and broad topics, but we will specifically discuss one on bicycle mode and another preferably on automobile mode, that is more or less to car mode. So the traffic scenario in India, all of you know, is highly heterogeneous. There are roughly 22 types of vehicles having different dimension, weight. They are moving on roads. That's why very complex to do any sort of analysis, and any standard code that is available from the international literature perhaps will not work in Indian scenario. So another aspect is that we don't have lane discipline. We have this lane marking only at very few sections. Even on those sections, perhaps we don't follow our lane discipline. So the thing is that we always try to optimally utilize the space that is available laterally and longitudinally. Lateral means across the road section, longitudinal means front to front vehicular interaction. So that's why before going for any sort of improvement proposal, we should very clearly know what is the status at present. What are the influencing parameters or factors? Those really affect to the service quality. Then we can do something on priority basis on those parameters so that we will get maximum benefit. So this way we will proceed one by one. So the problem statement, all of you know that because of our highly heterogeneous traffic and we are not following lane discipline, so the users, particularly the bicycle mode users, they are being deprived, their service quality is not taken care. So we have to give or try to give some facility, but not at the cost of losing or decreasing any kind of service quality that the automobile mode is availing in the present scenario. So that is something we should try, and then only our non-motorized mode of transportation, which is a green mode and is very much required because of our lifestyle. So there is some scope that we will get some physical exercise and at the same time less pollution. So we try to find what kind of service quality the infrastructure. Again, the infrastructure are broadly, you can say, are of three types. One is urban street mid-block sections, one is signalized intersection, and another is unsignalized intersection. So broadly, three facilities we are considering. So on these three types of facilities, what kind of service quality, the mode wise, whether you are considering pedestrian mode, bicycle mode, automobile mode. Under automobile mode, you have car mode, then three-wheeler, bus, truck, etc. Individual mode wise, we can also assess the service quality. But most of the manuals or codal provisions that we are following, they take it in aggregate form. You know? And in India, of course, this bicycle level of service, or here we are representing as B loss. Similarly, automobile level of service, A loss. You know, this B loss mode of transportation service quality, perhaps no one has done any in-depth work. So that's why we have selected this topic for detailed analysis, and our suggestions and the limitations, those things also we are going to discuss. This is the overall framework of this study. I think all of you know that we normally go through very extensive literature survey, then the methodology, we try to fix study area and data collection procedure. Several cities are there, then we have to select some cities. So based on what criteria we are selecting some cities, what kind of variability, those things depends on us. We have to select the cities. It can be metropolitan cities or mid-sized cities, or some case it can be mixed up. Then we have to judiciously take the decision from which city we should take the data. So then next level, we have to identify the variables, because there are several variables you can find from literatures, and then finally we have to select some of the important variables. If you take so many large number of variables, then it will become very difficult you to manage in your modeling process. So that's why we have to apply some statistical technique and limit the number of variables to 5, 6, 7, whatever we can control, or variables having significant contribution. So the bicycle level of service modeling for street segment, the signalized and unsignalized, three types of facilities are considered. Similarly, for automobile level of service, then we do some kind of sensitivity analysis. Sensitivity analysis is at the last part. Once your model is fitted, then you have to check which variable is contributing how much. Accordingly, we can tackle the most influencing variable first and next second, like that. That's why the sensitivity analysis. Then ultimately the improvement strategies we have to formulate, whatever the research output we are getting at the end. The field engineers or the planners who is there in the field, they need uh, strong collaboration with academician researchers, and that way the society will get the real benefit. Um, Broadly, we are discussing about two types of tools. One is statistical tool, under which stepwise regression, order probit, order logic. Then under artificial intelligence tools, genetic programming, multi-gene genetic programming, functional network, then BRNN, Bayesian regulation neural network. So many others are there, but we have discussed this much. Some of the very popular techniques in the recent past, all these AI tools are being used in transportation problems. Other statistical tools that are traditionally used, then we will see that which method or tool is giving better result. We can give some comparative statement or comparison we can do, that we'll see. So the study area, in fact, collecting data in India always, is very difficult. So we have taken data from several cities. You can see Considering the different Indian cities, consideration different parts of the city, then diversity in the geographical properties, traffic characteristics, roadside developments. The purpose is to include much more diversification in their characteristics in terms of geometric, in terms of traffic, etc. And cities considered like Bhubaneswar, Lucknow, Rajahmundry, Nagpur, Raulkela, so many others. Okay. So this is perhaps one strength of this study. And when you are using these AI tools, artificial intelligence methods are always data hungry methods, all of you know. So we must have to generate more and more reliable or good quality data sets to get better model. Less data, not so good model. So that's why we have to do a lot of exercise, because in India we have to do a lot of field study, which is practically very, very difficult. And we have to take help of our PhD master students, and normally they visit to different sites, collect the data using video camera, and getting suitable sites on the field is really another challenge. Getting permission from the police authorities, and several, then coverage, the video quality. So those things are, weather condition, and again, when you are, academic researcher, you have restricted time period on that particular time period, preferably on the working days, peak hours, data are being collected in the different time period. Similarly, for signalized intersection, 70 approaches are taken into consideration on signalized intersection. 70 approach legs or data are taken into consideration in the model development process. These are the locations in Bhubaneswar and all, Nagpur, Lucknow, etc. So this way, a lot of emphasis was given on the data collection part. And we require some high resolution video camera, measuring tape. Nowadays, you have different way. Without measuring tape, you can also measure the distance. Laser meters are there. And of course, through this video camera, you can get the traffic operational data, then geometric data we can measure using the measuring tape. Or similarly, the built environment and other data that we have to take from the field investigation, their perceived satisfaction level of the user. The users are, of course, your bicyclist or your automobile, depending on the mode on which we are collecting the data sets. This is another challenging aspect, getting perception of the users there in the field itself. That's why it is more, accurate, because the users have their feeling, they express on the moment. The other way, we can do the same thing through Google Form. We can send to several users, or there is another technique. We can take small video clips and display at some, say, AV hall or some common room where many other users, maybe your friends, like, so that you can uh, give them the questionnaires, and they go on filling the questionnaire, looking the different video clips, different ways. This perceived uh, perception method is being applied elsewhere also. Then it depends on us how detail form we are taking this data. Under geometric data, we have several variables. You can see here number of traffic lanes, total link length, total number of driveways, frequency of driveways, etc. Carriage width, you can go through. Similarly, traffic operation data, mid-segment traffic volume, average traffic speed, standard deviation of vehicular speed, etc. Built-up environment data like roadside commercial activities, pavement condition index, street lighting, etc. So the data sets that are taken, I mean, how we have got these variables. Of course, literature helps, and when you are conducting the pilot survey, that is means first time survey, then you have got the first impression. Then only we can have our final questionnaire design, and those variables we have to measure. They are in the fields. Okay. So likewise for signalize and on-signalize intersection, of course, there will be some difference in the data variables. It is not same. And so this extensive data collection, variable selection, that really strengthen our in-depth analysis. This perception survey, already I told you who are involved, um, like persons having more than 40 years, normally we consider for bicycle mode, above 18 years for automobile modes. Then number of samples data, that means user participants, it depends on us. More is always better. And there is some erroneous form of data, always you know that we can eliminate. Sometime we also take help of mirroring. If you are having very less data sets, then there is some technique we can increase the data points. And so the data points has to increase. I mean, has to be significant. So, and there are some techniques or mathematical expressions using that we can say that whether our data sets that we are using are good number of data points for the purpose or not. Statistically, we can satisfy that. We can get it very simple formulas are there. Now we can proceed a little bit faster. I mean, this service quality, all of you know that on any facility, we are concentrating here on road facilities, particularly say mid-block sections, signalized or unsignalized intersection, and some mode-wise facilities. For all different cases, this range will be vary. And conventionally, this is taken a variation from 1 to 6. Normally, A is the best quality of service, F is the very worst, not so good kind of service, and average, C. So any infrastructure, we always try to maintain C, minimum C kind of service. It's better B, A, but practically it is very difficult. And India, population density is very high. So that's why practically it may not be possible, but if the service quality is deteriorating, is going towards D, E like that, then we try to take some action and improve it to C level. Road segments, that is from after one junction to next junction. Likewise, here this bicycle level of service, modeling. For that, you have 8 variables. Initially, it may be 15-20 variables. Because of this Spearman's test, correlation analysis, that p-value, all of you know, we can say which variable should be taken into consideration and which variable should not be taken into consideration. Clear? So that is the first step of our modeling. Now, data processing. All of you know that when you are developing some model, then you have to validate your model. So to validate your model, you keep some data aside, 30% of the total. That will be useful later on. So in most of the modeling cases, when you are using only 70% data, we require more data. Then something database normalization. This, scaling 1 to 6, A, B, C, D, F. In some cases, it will be different. So in order to bring all of them into a single platform, we follow some kind of normalization, 0 to 1 scale. Then again, we can denormalize it. Normalize it, then next step. Okay. So that will help in our model fitting. This is our contribution, modified rank index. All of you know that when you are doing some kind of modeling exercise, you apply some error estimation techniques. All of you know this is something called best fit calculation, R square value. This is, we have taken R1. This is our contribution totally. This is called MRI, modified rank index method. Normally, we see all these are available, then we try to combine them together and develop this MRI method. R2 is error measuring using average absolute error, maximum absolute error methods. Likewise, well established method. Similarly, R3, I'm not going more depth, but you can have a look on it. And if you want to know, then you can email me. My email ID is there on the top. R4, R5. Say then what we do, suppose for regression based model, order probability model, order logic model. Oh, these are statistical techniques. Again, you have GP, MGGP, FN, BRRN. 6, 7 methods. You have applied all these. Now, how can you know that which method is better method or best method, you can say, or worst method? So then we are doing training, then we are doing testing, 70%, 30%. Then we try to find the best fit calculation, error measuring parameter R1, R2, R3, R4, likewise. Then what you do in the first error estimation technique, we have suppose 7 methods we have applied. Based on those output, we can rank them. This is the best one, suppose FN method, using this error method. Similarly, error measuring second method. Okay. And in all these cases, I think it is FN method. Yeah, I think FN. That's why when all of them equal 1, 1, 1, 1, so the summation is 5. You know? So that's why the functional network method is the best method we can say in terms of error estimation. And the second best is 2, that is MGGP, multi-gene genetic programming method. And 3 is your genetic programming method. Yeah, likewise. You know that the regression method, which is so popular and most user friendly, we love to use those kind of models. But in terms of prediction or in terms of errors estimation, it is not performing so well. So that's why people are going after these artificial intelligence or machine learning approaches. So perhaps this is one interesting thing all of you can appreciate, and this is very much useful whoever is working on modeling, and it has got appreciation on several papers. We have used it, and for application you can see more. If you want, you can download some of our papers from ResearchGate or Google Scholar. You can see and have a look on those. Yeah, I think already I explained these things. This is about the perceived B loss score and predicted B loss score. Why this is score? Because we have some geometric variables, some trophic variables, some perceived variables. That those are our x variables, x1, x2, like. And y variable is our perceived or B loss score. Ultimately, we are getting some number figure. Again, I told you this figure or the output can be different number. We can normalize it and bring into some standard one. Okay, because we have several models, and so that way we see for this is facility wise it can vary. So just one we have discussed was about mid block section, say. In signalized intersection, it can be altogether different. Not necessary that FN method is number one. Some other method may come number one. But more or less, all things are repetitive. Now the model fitting part, we have to fit our equation. Always the regression based equations are more popular. Again, under regression based methods, we have linear base and we have non-linear base equations. We can develop. What our experience says that the non-linear base models, this is one non-linear base model, which is difficult to establish, but it will give much better prediction than linear model. The R square value you'll get better and you will get more appreciation in your research or paper. So we should try both. Then only we can say which is giving better result. So for this, we have to do a lot of trial and error, but finally we'll get some good models. In the similar form, this MGGP and so many other techniques, these are being developed under MATLAB based, computational techniques. Nowadays, some other techniques are also available. So for that, we required, this algorithm, population size, it has variation this to this number of generations, etc. So what finally we have followed here is these things. And here the important thing in this method is establishing the weightage for, in our particular case, this number of genes can be, we can decide, and that decision depends on R square value where you are getting the maximum. So accordingly, we have selected 3 and the coefficients we have got, and those are utilized here in this one. Coefficient W0 is being utilized here, and the remaining W1 weightage factor 2 for gene 1, gene 2, weightage factor 3 for gene 3. These things has to be calculated, and those calculated values somewhere here 0.041, 0.486, likewise. And of course, variables are ours only, depending on the type of problem we are tackling, transportation, mechanical, or whatever structure, etc. So that way, overally, this equation you can see here seems to be more complex. Any normal users in the field will fear to use your equation. Its prediction efficiency is very high, but question mark is on usability, how the users they are taking your models or output. Similarly, this is the functional network based BLOS model. So the safe function SF is being considered for polynomial, exponential, and other. And in that case, the maximum R square value we found is about polynomial, and that is considered based on that, depending on our variables that we are considering. We are trying to establish some equation, and it is so complex. So this is something about one mode of transportation. We are talking about bicycle. Again, under bicycle, we have, sorry, under bicycle mode, we have considering mid block or segment type, other junction. Similarly, we can develop such kind of very complex equations. So once you know the technique, now it is simple. Like this is a loss model, automobile level of service model. I think things are mostly repetitive, what we have discussed so far. Only thing is that there will be some variation in the variables that we are considering, and remaining, I think most of the things, will be equation looks to be a little bit different, but overall the approach is same. Similarly, the MGGP LS model, yes, functional network based LS model. I mean, our target in the beginning is to get or assess or predict bicycle service quality. The bicycle service quality here in India, whatever we are getting, it is purely on shared path. Hardly you will find any bicycle lane facility. In some Western countries, you will find exclusive bicycle lane. Some pedestrian lanes are there. Sometimes these unwanted bicyclists, they use pedestrian path, you know, but that is separate issue. And whatever we have done here is just purely on shared path. The shared path, again, you know that lane wise, if you see the utilization, the innermost lanes are normally being utilized by high speed vehicles, preferably the car traffic. Next to that, that is heavy vehicles, truck traffic, bus, etc. And the outermost lane, or we say curve lane. close to our footpath. So you will find much hindrance from vendors, encroachments, our Indian scenario, stray dogs, um, whatever, signboards, advertisement boards. So the vehicle normally travel at slow speed, and on that bicyclist share his space, and so that's why on that only we have considered that is the case. But literature, whatever you will find, particularly for Western countries, they have um, exclusive bicycle lane, and we have not considered that. Similarly, here in this case, a loss model, we try to find or what is the error, regression base, MGGP, and FN. Depends on us how many number of models we are developing and compared. Here in this case, perhaps MDGP is showing better result. So likewise, now the question is, when you are developing such kind of model, then we have to see its prediction efficiency. How we can check the prediction efficiency? One is our own model. Again, models are of different types we have developed. उसमें जो, I mean, in that there are so many types of variables. Those variables values, you know, if you give those variables as input, obviously you'll get the output. That output is some score, and that score you can define its ranges A, B, C, D, F. So finally you will get some uh, so this is called A, B, C, D, F, Likert scale 1 to 6. I know this alphanumeric values shows where we stand at present scenario, field observation, and our model prediction. Both we are trying to match them. You know, their question is how to know field observation. Of course, we are going to the field. We have the perceived values also. You know, so that way, which one is showing the maximum matching? Perhaps this one, MGGP model. So perhaps this is clear what I'm talking, because we have several X variables. The values we know in the field, giving it input, we are getting the output value. Accordingly, the score and the score where it is falling, we are just trying to match, percentage wise matching. So this is some application of our developed model, you know. So now this is perhaps another close to our last part of discussion, sensitivity analysis. The sensitivity analysis, you know, so you can summarize the whole thing about modeling what we have discussed. We have taken some variables, restricted some variables, eliminated some variables through some statistical text. Once you are taking some variables, then we are trying to fit in some equation or model. Once you have several models, that is, you are getting your, you know, training and testing phase. Yeah, fine. Then model is fitted. We can check, observe with our predicted, that is how much they are matching or not matching. Then once you know which model is best for you, say for any kind of facility, maybe segment or signalize or unsignalized facility, then our job is to know further, that is through sensitivity analysis, because number of variables, those things are already fixed. Among those, again, we have to see which variable is contributing maximum. Suppose this is one case, 38.31. Another is contributing 21.86, second contribution. This is 12.68, third contribution. So when this variable is contributing so much, if you add up all these, it may come towards 99, 98.5 or something, may not be 100. No, at this case it is 100. In this case it should be 100. In the previous case, when you're eliminating some variables, that case perhaps there will be a little bit difference. But here in this case, when we know that based on this method, say FN method, this is the one high, so we should try to do for this variable. Percentage of heavy vehicles per lane, perhaps that is the one which is contributing to the maximum. So if you do something for that variable, then your service quality will increase. So any system, any facility which is giving service to us, the approach is same, whether it is at road transport or any other system. Now, once we do such kind of sensitivity analysis, then we can tell something, because these variables what we have taken, some variable can be increased, some variable have positive effect when you decrease it. Like here you can see decrease the influence of this, decrease roadside parking amenities, decrease roadside commercial activities, enhance pavement condition index. So likewise, it gives us strong conclusion. It gives us our approach towards field application. Because ultimately, whatever research we are doing, people want to know in a summarized form. Tell me what I should do on priority basis so that I will get the maximum benefit. Straightforward manner we can tell them. These are the effective bikeability improvement strategies. Same thing, we can have to see literature wise how we can write, express those things. Removal of obstruction in the outermost lane, conversion of wide outer lane into travel lane, provision of bypass road for motorists, enhancement of pavement surface quality, stop signs at high volume driveways, etc. These kind of strong recommendation we can give. This is all about junctions. These are simply repetitive things. We can have a look. Yes, again, sensitivity analysis for junctions. We can see which one is influencing the maximum, and yeah, variables are different. Then we can say improvement strategies like the other facility. Here also for signalized as well as unsignalized intersection, we can do something. In some case, minimization of bicycle delay. That steps what we can do here. Effective traffic management, proper signal coordination, separate bicycle signals. Most of the case we don't find bicycle signal, minimization of influence from crossing pedestrians, turning vehicles, traffic flows, and the subject approach, etc. So we can do something. So in summary, what we have discussed, the data sets has to be sufficient, wide variation should be there from different cities, different geometry condition, traffic condition, and that is better. Your model become that stronger. This is one difficult part in India. We have less automated data collection systems. We are reluctant to share our data sets, but still there are a lot of scope we can do on data automation and implementation. In fact, sometimes we are reluctant, but that way the research quality, the output, data quality, etc. will enhance significantly. The tools, whether it's a regression based tool or AI based tool, all are available. Only thing is that we have to go forward and apply them. Perhaps India is very good in applying all these tools. So only difficulty we are so far is about quality data sets, share of information or data sets. Then the whole things will become very good for us. Now, of course, another difficulty is about application, how quickly you are applying your research output. Of course, the best method always we try. Those best methods, algorithm, we can use in our software. We can develop our software. So that way the prediction efficiency will be very high. And for the future, because the whole job we are doing not for the present. Our target is for the future. So that's why we are doing the whole exercise so meticulously. So the strategies that we should make in a very clear-cut form from our own observations, means from our data sets, models, output, sensitivity analysis, technically, those things we can share with our field engineers or say planners. Then they will accept it. And just simply verbally, if you express it, perhaps there is no basis for that. Now, conclusions are complex, and for B loss, some variables which are contributing or influencing significantly at signalized in mid block sections, those are identified. Similarly, for A loss, variables are identified, different techniques are applied, which is giving the maximum R square value for those things also identified. So we can strongly say this MGGP based model is good for B loss prediction, say for segments like that. And improvement strategies we have there in our hand, so we can go accordingly. That will give you the best result from the research, meticulous research with so much of time. I mean, others, like ours is a developing country, so research is definitely costly affair. Of course, over time period, we are spending more and more money on this. And so that way, we hope our road system, traffic management, which has an implication in the transportation planning, and not only planning, in the maintenance systems, and because maintenance system is also very much linked with our traffic flow. So the whole exercise of doing this thing is only to have a very good high quality road system, transportation mobility system, very good information system to the end users, so that optimally we can use our resource and we can get the best service quality. That's why we are estimating the service quality, we are predicting the service quality. So the service quality concept is well established in US. They have started in 1950 in the form of highway capacity manual, and in India recently we have our Indo HCM, but we have a long way to go, very extensive, comprehensive, um, capacity manual, service quality manuals, and all these things. We should not only do it once, but at interval, we should include more and more latest techniques, and so that our system will be much better. So thank you for listening very patiently, and perhaps um, this topic is interesting for all of us, and so that way I stop here. But if you have some question or queries, and then I request Sujit, you can convey me, so I can tell something, or if you have more in-depth some questions still which we cannot because of time constraint, then my email ID, you can the top, you can see BHUYN Bhunya P for Prashant @nitrkl.ac.in. You can email me and I will try to convey the best possible answer for you.
Okay, sir. Sir, please stop sharing. Stop sharing. Okay.
Yes.
Thank you, sir, for giving a nice lecture and presentation. Sir, participants have asked some questions. If you permit, then I will convey to you.
Yes,
Yeah,
sir.
yeah, okay, sir. Thank you. Sir, first question. Pavement potholes or rotting may have more impact on cyclists in different weather conditions. Also, the
Mhm.
socio-demographic characteristics of cyclists,
Mhm.
for
Mhm.
example, depend upon the age or gender, whose
Mhm.
patterns are also very difficult to predict before. Are these
Mhm.
related to bicycle level of service and
Yes,
how?
yes, it is very much related. And we have taken care. So that's why this parameter that is influencing to the most. Your question is very much appropriate, and it has really very significant variable. And after the sensitivity analysis also, this variable is coming in the rank number one in one of the,
Okay.
I think, one of the facilities, like different other facilities are there, and so that way.
Okay, sir. Thank you, sir. Sir, second question.
Regarding the
Uh,
demography, yeah,
sir.
we have also taken care about the demography, the age. I mean, like I sometimes to tell that bicycle age is something we have considered 14 or so, like that. Then for automobile, more than 18 or something, and of course, location to location, those things can be taken care during your perception-based survey that time also.
Okay, sir. Sir, second question. As we observed, around 95% of the studied segments are offering average BLOS or inferior service quality for this bicycle use.
Huh.
But the performance of existing facility may be degraded over time period due to several
Uh,
reasons,
uh, uh,
including a gradual increase in volume, increase in commercial
uh, uh,
activities
uh, uh.
within the urban area. Also, there is a degradation in the payment quality. So, how this model will help in a long term transportation planning and assessment of on-street bicycling environment.
Hmm. Yeah, for this one, again, this is a very good question. So, as I told you, that over time period, the road which is offering better quality service will, of course, may not able to provide the same kind of service over time period. So, the model, in fact, has taken care about the whole thing. So,
Yes.
that is the whole purpose of doing so rigorous exercise. So, one is called the business as usual condition. That means if you are
Exactly.
not doing anything, then we can say the traffic volume is going increasing. All road condition will also go on deteriorating. So that way the service quality which we are getting at present C will go further down, maybe D or E or something like that. So we have to do something over time period. That's why it is a kind of, making you alert, you should do something.
Sir, one thing I have seen regarding traffic engineering or transportation planning, in foreign they are adopting all the methods, whatever we have studied from various journals. But in like in Odisha, I think not
Yeah,
that
yeah, that's a very
they
good
are not.
question. So in 2007, in the World Conference WCTR, I have attended in Berkeley. So there,
Yeah.
one Japanese professor, he stand and stood and he told that in Japan we apply our research output very quickly. Why it is so slow in US?
Okay.
the similar kind the similar kind of thing you can also, I mean, it is basically our mind setup, and of course we are changing. I mean, the things are changing. We cannot say that it is not. That's why we are getting better quality road. But regarding
Mhm.
the traffic planning and its acceptance, it still need quick action,
Ah.
acceptance.
Also in during our NHI or Mahatma that PMJSI roads
PM
also,
Jason. Uh-huh.
sir, we are correcting the DPR like that. Just that they have projected this is the total number of bicycle and the MSA. By that MSA, that severe value, then what is the thickness of the pavement. But they are not concerned about that footpath, what will so weight or whether there will be road or intersection will work or not, bicycles. But they are not considering actually. Just they are concentrated only the payment. But
Yes, yes.
traffic,
It
very less actually.
In India, still we don't consider traffic transportation engineering is a subject of interest, or it has some, I mean, wide application. Uh, हर कोई भी, I mean, anybody can do traffic studies. He can predict. He can
Yeah, exactly.
like that. So we have some kind of, but definitely, I mean, with time period now we have so much of specialized people
Exactly,
and
exactly.
at academic institutes in the fields. So things perhaps are not the same which it was 20 years before. And of course, after
Exactly.
20 years, you will find there is a lot of change.
Actually, payment, we know that payment construction is 80%. Okay, that's okay. But traffic planning, traffic designing, that is, and I think that is 80%. It should be 80% overall. Out of 100%,
If
it
you
should be 80%.
if you go to some of the TRB session or some of the very large scale conference, then you
Exactly,
will see
exactly.
how much diversified this field is. And planning is so big, then there are so many other aspects we are not touching those things. So, in
Okay,
fact, if you want a very good network, and network means, in a transportation network, it seems to be very simple thing, but the network is so complex thing. So, I mean, we have to consider the whole transportation system as a whole, not piece by piece, and integrated
okay.
the system. So that way, I think, yeah, things are changing and it will change.
Okay, sir. Thank you, sir, for giving a nice lecture also and answer to various questions queried by the participants. And thank you once again for giving a valuable time. and it may be probable it will help all the participants or engineers or faculty members to help in future for transportation planning, designing, anything. So thank you, sir. Thank you once for joining with us. Thank you, sir.
You all the organizing team, and perhaps so many members are there. I perhaps don't know many members because I'm from
Yes, sir.
outside. So definitely there is hidden effort of so many members. So my thanks to all of you for giving me this opportunity, and it is really very nice to share whatever we have with our community, or say the members, or who want to know something in this area. So that is also, this is a kind of problem for all, you know. This is not only my problem
Exactly.
which I am facing every day. This is everybody's problem. So we are, all of us are contributing, and over time period we will get better facility. Thank you.
Okay, sir. Thank you, sir. Thank you, sir.
Thank you.
Okay, sir. Thank you.
Okay.
So, dear participants, welcome to the second session of ARC Automation and Robotics in Construction Industry. Today we have with us Dr. Antarjay Mishra sir. He has more than 35 years in teaching and industrial experience, and he has started his career from L&T to as a assistant professor, associate professor, professor, and director at IIT Sarang. Uh, Also, he has completely dedicated his professional life for the development of faculty and students of IIT Sarang. Now he is working as a state project administrator, TechCube 3, NPIU New Delhi. Finally, we may conclude. I will not take much time because all participants are aware that who is Dr. Antarjay Mishra sir. He is the known face. So finally, we may say he is an engineer, academician, motivator, administrator. So welcome, sir. Welcome to our workshop, jointly organizing by Civil and Production Engineering Department. So I would like to request Dr. Attajami sir for sharing his thoughts. Uh, Thank you, sir, and welcome to ARC 2021. Sir, before that, I would like to request Antajem sir to say few words to our participants.
Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you, Dr. Pradhan, for
Sir.
giving me this opportunity to
Thank you,
speak a
sir.
few words on your webinar or faculty development program as far as automation in construction industry is concerned. In fact, you have chosen a misfit to a group of fits. You are all fits, and I am the misfit or the odd man out who has
No,
been
no, sir.
given this chance to speak on civil engineering. I am a man from mechanical engineering, and maybe by virtue of my experience or what I see which is going around the world, that I will be speaking and I will be sharing my experience with you, and I will give you some food for thought as far as this topic is concerned. Anyway, I do not know since when you have started this program, and I thank participants, those who are present, because probably it is the last session of today's
Yes, sir.
program, and people must be getting very much bored. So that's why I will not be taking much time, because I am not that much knowledgeable in this particular field. So whatever I see and what is going on around the world, and whatever I have learned from all of you, not from others, but from my faculty members or civil engineering experts, and what I see in my naked eye from the world, that I will be sharing with you. In
Okay.
fact, let me start. That is better. I wish that the participants will be having some patience to listen to me Otherwise, if it is excellent, fine, you don't oblige me. Rather, if it is boring, don't tell boring. Please tell that
No,
it is
sir.
less interesting. And that will, I hope next time I will improve myself as far as this type of webinar is concerned. Don't tell boring, tell that it is less interesting. So I have got some slides to share with you, but
Yes, sir. Thank you, sir.
prior to that, can I share my slide?
Yes, sir. Yes, sir. Yes, sir.
Prior to that, I will be taking 10-15 minutes to discuss the preamble of such a situation. Now, is it visible?
Yes, sir. Visible. Make it full screen, sir. Make it full
Full,
screen.
okay.
Okay.
Is it now full screen?
Yes, sir. Yes, sir. It's okay.
Okay.
Yes, sir. Okay, okay, sir.
But I do not know how it is going. Oh, I have to touch
Okay,
this one.
it's okay, sir.
Anyway, so friends, it's my pleasure to speak to all of you. But prior to coming to the topic, I have got some ideas, or I have seen what is going on around the world. If I go back to the traditional way of construction in India, then you will find that massive amount of labor was engaged, then safety of the workers was not considered, then there are cost overruns and projects are not completed in due time. As a result, this type of automation is very much necessary for all of us. I will not be speaking about India, rather I will speak about the project execution as far as civil engineering is concerned in Odisha. Friends, in Odisha, I have seen that the Talchet Bimalagarh railway line is under survey. 10% work has been done. Laying of railway tracks is taking considerable amount of time. Maybe due to the fact that funds are not available. When it was estimated 20 or 30 years back, you will find hardly 200 crores was estimated. Now it is 2000 crores. Similarly, I am talking about railway connectivity. So, Khordha Balangir railway up to Nayagarh we are able to do in 25 years. Further is not possible. Same situation I have seen. Those who belong to Sarang, they can see that there is a flyover which is constructed in Saimpal. That's a overbridge or a flyover, whatever you say in your mind. I have seen that it was envisaged in the year 1973. It was completed probably around 2015 or 2016. That means it took around 42 years for completing a flyover. Massive amount of money has flown. There is a cost overrun and nobody checks the quality. Only time will say at what quality and with what safety we have constructed this. Apart from this, I have also seen that in Bhumikal there was a collapse of a flyover. Reasons may be plenty. I am not here to tell you how many people died or who was responsible or who the engineer was. Similarly, there was a collapse of a flyover at Sambalpur. So these are certain examples that I am telling you, which has urged or forced our engineers to have a rethink that how best we can construct flyovers, how best we can construct roads which will not be damaged very quickly. Because in most of the roads, what I see that forget about national highway, whether it is national highway, I am talking about roads only, or expressways, or major district roads, or rural roads. These are the four major categories of roads that we construct. Earlier we were constructing blacktop roads. Now we are going ahead with concrete roads. And cost is high. but the life may be better. But you will find that while constructing the roads, we see that after one rainy season, because of the clogging of water, the blacktop roads are destroyed. There will be maximum number of potholes. Accident, it becomes accident prone. Please don't think that I am speaking ill of anybody. I am speaking about cost overrun, or I am speaking about other things, because human safety is of utmost importance, and similarly, economy of the state as well as economy of the country. I agree fully that civil engineering is the bedrock of all engineering, whether it is border roads or a bridge or a flyover or a road or a connectivity by railways or connectivity by ports, whatever it is.
Hello,
That is the
sir.
beginning. That is the
Hello,
beginning
sir.
of civil engineering. Anything, Sujit, you want to speak?
Sir, the slide is moving, not moving, sir.
Not moving. I am just
Okay,
giving the
okay,
preamble.
okay,
Right?
okay, okay, okay,
So
sir.
looking into
Okay,
these
sir.
problems, I thought that automation in construction industry is of utmost importance as far as India is concerned, and our state, Odisha, is concerned. I am a man from the state, so I will be focusing my talk to this. So, in a, if I summarize what I am going to speak, I will be speaking on the traditional way, what we are doing and what we have got. I will be speaking about the tools that were used earlier and what are the tools that is used now. Then again, the third step of development, I will be speaking something about the newly invented robots which are used for construction industry. And finally, the benefits, the advantages, the disadvantages, and certain food for thought I will be giving you. So I will be completing by 5:20. Now it is 5:20. Please don't get bored. So friends, I am going to the next one. I am showing you some pictures. Today we will only see the pictures. The first one is a flyover that you can very well see. Second one is a national highway or whatever it is. And this is what? This is another flyover. You see the construction near the ocean and see the construction where there is a heavy vehicular traffic and there is a tunnel and there is a runway. I'm trying to cover, just show you some pictures so that you will have some idea what is the importance of civil engineering as far as connectivity and other uh, community development activities that is being taken up by civil engineering. And this is a bridge. This is another type of bridge, which is a rope bridge. The design is very much complicated that you can see. And these are certain skyscrapers. This is not the Petronas building of Kuala Lumpur, but this I have collected some photographs from your Google search. And the next one is a dam. This dam, you see, I have shown one type of dam. Usually dams are being made for irrigation purpose, for flood control, for drinking water supply, and also for power generation. So various types of dams are being constructed by our civil engineers. And sorry. And this is a roof truss which has been designed for providing to as industrial sets. And the last one, whatever I have seen, it is a ready-made house. You might have seen that the Tata group of companies, they are now providing vending zones as well as small shops and also habitable houses, also some small cabins on ready-made basis. It's available and you will find that a house is being made within 2 days or maybe sometimes within 1 day. And that is because of automation. As far as automation is concerned, I am showing this slide to all of you because human evolution, I will not be speaking about Darwin theory or any other theory, but human evolution you can see from the picture, and finally the man is sitting and reading. Fine. Similarly, humanoid evolution, it is a biped system of robot. You will find that we have come to a stage where robots are there. I mean to say, I can say jokingly that robot becomes a second wife. If you are married, fine, it becomes a second wife. If you are not fine, married, then it becomes a wife, your wife, who will give you a steaming cup of tea in the morning after getting up from the bed. These are certain traditional activities. You can see in my first picture. This is my first picture where people are working, and this is second picture where motor mixing is going on, and this is third picture where a roof casting is going on. All of you understand that this type of things are being done through manual labor, which takes considerable amount of time, including transportation and other things. Okay? So, hard labor is necessary. Safety is not taken into consideration. This is the traditional way how we construct the house. But still it is in use in our rural areas and also in our urban areas in India. We have not completely eradicated this. Now, I will show you the transportation system. We call it as a bullock cart technology. Initially, from one place to the other than using human beings, we are using a bullock cart. Right? From bullock cart, you see the cement bag is carried out by means of bicycle. After that, you will see that there is a tricycle. And this tricycle, the man is loading bricks over here, doing some civil construction work. Finally, we are coming to a auto rickshaw, or now it is electronic rickshaw, and a tractor, and a six-wheel truck for transporting materials from one place to the other. And here you will see that 16-wheel trucks are also available. Why I am showing this? This is the development that we have come across, right? And we are using it. But what the next? That is a $1,000 question. So, we have utilized all those traditional ways and still we are using it in rural as well as urban or semi-urban areas. But automation is necessary because when the job is totally repetitive in nature, and it is too much time consuming and it is dangerous. Because if you are working on a skyscraper, you have to climb up to the extent of 100 feet or 200 feet. If it is a 21 story, maybe 200 feet. If it is a 10 story, around 100 feet or so. So, the working environment becomes dangerous. As a result, safety of workers is not taken into consideration. Similarly, cost control. Whether I have already given you the example of laying the railway tracks, and reasons may be plenty, but there is no control on the cost overrun is there. And increased efficiency is necessary. And construction industry is not an exception to this. So the excellent solution for this is operational efficiency has to be increased and cost to be controlled. Need of construction automation and its benefits. It starts, the scope of construction automation is wide and involves the entire construction stages, for instance. That means the construction materials for civil engineering, we say know that sand, asphalt, segregates, cement, water, and iron as a reinforcing agency. Or if it is a composite material, other fibers and other reinforcing agencies are essential. So, construction material production how rapidly we can produce. That's why automation is necessary. And how accurately you can produce. Sometimes prefabrication of construction components are also necessary. You might have seen nowadays that pre-stress concrete or precast uh, concretes are available, for which it is taking less time for constructing a flyover or a bridge or laying down the railway tracks. And on-site construction is very important. So many challenges are there in on-site construction. And operation, after construction, operation and maintenance of the buildings. People forget after constructing, usually they forget the operation and maintenance of buildings. And last but not the least, it is the demolition and recycling of structure. For demolishing a single-story building of 2 to 3 rooms, we may take 1 month. But nowadays, it is becoming easier because of the equipment that is available. But after that, how to recycle these things? Otherwise, there will be environmental impact. So that's why automation is necessary. Various issues which are related to construction. Automation is necessary, that is low quality of a final product, shortages of skilled labor. Every time you will not get the skilled labor, you may get semi-skilled or unskilled labor. And mostly in our rural areas, you will get unskilled labor in plenty, skilled labor very less, right? And safety of labor is of utmost importance. Poor weather conditions and short construction period, which nowadays are features of a project. So, if automation is taken into account, the construction work will be continuous, the construction period will decrease, and large economic advantages you will get, and safety of labors and quality of the work is increased. So the scope of automation in the construction is quite broad and extending from initial planning stage all the way to operating and maintaining the final structure. What are our opportunities? Our opportunities that automation of traditional physical tasks on site, robot laying bricks, and machine paving road. In civil engineers, those who are present here, they might have seen that the pavers are available for constructing roads. And now, earlier, physically, people were doing the work for putting the bricks in order to construct a wall or a foundation. Now, we are thinking of one automation in this area. And automation of modular construction in factory. What is that modular construction? That means in a single piece, you can construct one particular part. That is now 3D printing and additive manufacturing has come into existence. It is picking up gradually. It is mostly in India, we have not used 3D printing to a larger extent. Recently, we have trained our engineering students as well as faculty members to get into 3D printing and additive manufacturing. That's a mechanical subject, but application to civil engineering in facade design and facade construction will not be a problem. Similarly, digitization and subsequent automation of design, planning, and management procedure. This most of the times we forget. I am giving you one example. When we were studying, I will start all our branches, whether we belong to mechanical, electrical, civil, or electronics telecommunication in first year, we were having a survey. And the practical is conducted outside the premises of the institute building, either a chain survey or a survey with a ranging rod. That I have seen and I have done it. Chain survey as well as ranging rod. Finally, I saw one good machine which is a theodolite. So theodolite survey we have done. But nowadays people are taking that developing equipments which can go for GPS system, right? GPS system, global positioning system. And they are also in today's talk, they are talking about drones, which is fitted with a camera and can develop the real image. Earlier, we were doing the survey, then going for a contour map so that at different heights we can see that the road is leveled or not leveled, or where to construct a road. So that was the traditional way, which was taking considerable amount of time. But now people are doing with drone camera, and that is also used in defense, in military activities, in research activities, and other activities. So, what is Indian scenario? Our Indian scenario is that our Prime Minister, Honorable Prime Minister, is talking that it should be Make in India, and there are smart cities. In 2016 or so, he has declared that 100 cities will be declared as smart cities. In Odisha, there are two. One is Bhubaneswar and another is Rourkela. And these are assets for the economic growth as far as infrastructural projects are concerned. Under the Make in India scheme, $1,000 billion investment has been done for infrastructure sector only. And urban infrastructure that are inadequate to meet the demands of the existing urban population. Why? Because there is a migration of people from rural area to urban areas. Most of the people, they are more interested, they are thinking that migrating to a urban area, maybe from Dhenkanal to Bhubaneswar, Kalahandi to Bhubaneswar, or Baleshwar to Bhubaneswar, or Berhampur to Bhubaneswar, or from even Puri to Bhubaneswar, everybody is interested that he will stay in the capital city, which is otherwise a smart city, so that we get all facilities. But I remember that when Dr. APJ Abdul Kalam was the President of India, he was talking about Pura scheme, PURA, providing urban facilities to rural areas. And that scheme has to be there to develop the infrastructure in rural areas so that we can check the regional imbalances of east, west, north, south of India, as well as we will provide all facilities at doorstep in rural areas. What are those facilities which are available in urban area? So, future cities of India will require smart real estate also and urban infrastructure. So that is what the Indian scenario, and 650 billion US dollars investment in urban infrastructure over next 20 years it is estimated. 100% FDI, foreign direct investment, is allowed under the automatic road, urban infrastructure areas like urban transport, water supply, sewerage, and sewage treatment. The Government of India in the Union Budget 14-15 has announced a project to develop 100 smart cities with 70.6 billion allocated in the current fiscal year for this same. Every year it is 70.6 billion they are interested to. What will happen? Job opportunity will increase, connectivity will increase, people will work safely, and their economic standard. I am not making a point, I am just speaking to you. Their economic standard will increase. As a result, what will happen? The per capita income of every citizen of the democratic country of India will increase. As a result, there is a economic growth. Basically, those who are not understanding gross domestic product, it is the product value termed in a current value, which you get from agriculture, from manufacturing sector, from IT sector, and service sector. So, IT sector, service sector, manufacturing sector, and agriculture, whatever produces you get, that becomes a gross domestic product. And that GDP must increase every year. And that will show you a growth pattern. Of course, due to Corona pandemic and COVID pandemic, our gross GDP has decreased, but still then we are trying to go for Make in India. As a result, our economy will increase. For making Make in India, infrastructure is a must. So, what are the areas of automation in construction? Those are roads and runways, structures, building construction, ports, tunnels, factories, and industries. Engineering automation, it starts from survey automation, design automation, construction automation. In construction automation, inspection, position automation, site monitoring, and machine automation. These are the 4 steps in construction. Usually in automation, survey automation, that I have already given you the example. Now people are talking about survey with the help of drones. As far as design automation is concerned, now computer-aided design is available because of the advent of system. In colleges, we call it as an AutoCAD system where you can develop 2D and 3D designs prior to its execution. And analysis can also be made in design stage by putting it through different structural analysis packages like START or START Pro or ANSYS or Avacos or Git or Nastran or Ideas. So many packages are now available which can animate the real life situation. But apart from that, now the concept has come to adapt virtual reality and augmented reality. The virtual reality is the simulation of a real-time situation or what is happening in the field so that prior to its execution, you can see what are the hurdles you are going to face and you can eradicate it. And inspection is a very important tool as far as construction is concerned, because how you make it so that it conforms to these standards, maybe Indian standards or international standards, whatever you follow, or you are following in construction industry. Construction industry not necessarily mean that it is civil engineering. It can be applied to mechanical engineering also. It can be applied to electrical engineering. In electrical engineering, we are having, you see, I am giving you examples for all the participants. In mechanical engineering, we construct by means of process of welding and applying production engineering for constructing sheds. And we are also taking the help of manufacturing side by machining and using CNC and NC machines and machining centers which are fully computerized so that accurate job can be produced within accurate time without any bias, and the precision is very high. Similarly, that situation of quality, if you are working on an ISO 9001 certification, then you have to conform to the global standards. Civil engineering can be up to this certification. Usually, Bureau Veritas Quality International, they give you ISO 9000, BBQI, they give you the ISO 9000 certification. So, the construction materials or building, port, road, they can be also considered with the certification where the vendor or the contractor has to be certified because of its quality, starting from the design stage up to the final stage. Then position automation. The position automation is by global positioning system or by means of a drone camera. You can quickly get what to give a position or where to place the work that you have completed and how it looks like, whether the aesthetic sense or the beauty of the design is taken into consideration or not. And site monitoring is a very important factor. In the site monitoring, how to monitor the workers. That comes under the category of management. Man and management and man, machine and material. The 3M management is necessary as far as that is concerned for site monitoring. And machine automation. How do you go about automating the machine? The machine should be such that it should produce within a less amount of time that would have taken or consumed by using the traditional ways. Number one, time factor. Number two, when you reduce the time, automatically the cost will be reduced. And if during inspection you have taken the quality materials, then a quality product will come. Otherwise, there will be garbage in and garbage out. So, machine automation is very much necessary. At a faster rate you have to do, at a reasonable cost you have to do, so that cost overrun is not there and the delivery schedule is taken into consideration. That means I finish my work or the job with a good quality, good reliability, good durability, and I have given employment to so many people, and they have worked satisfactorily. And it serves the purpose for which it has been designed. Uniform quality with higher accuracy than that provided by skilled workers that I have already discussed. Replacing human operators in tasks that involve, sorry, I have gone to, sorry. Replacing humans in tasks performed in dangerous environments that I have already discussed. What are those dangerous environments? Number one, you are working at a very high altitude, making a tunnel like water tunnel, or making a Jojila Pass in India, in Ladakh region, for giving connectivity to Ladakh as well as Srinagar. Or you are working, making a dam where so many people are displaced, or it is just like a theory dam. Or you are making a tunnel where you might have seen that in Uttarakhand, so many people, they died after the landslide. And or you are working in a hazardous environment. If you are going for a construction in chemical engineers, if they are present, they can understand. Chemical toxic substances, hazardous waste that is coming up. So making a pipeline or a drag line becomes very difficult. Or you are working in a nuclear power plant where you are working with environment of isotopes. How to handle those isotopes? Of course, we are using the robotics over there, handling isotopes, uranium or thorium, 232 or 134. I do not remember that one. So these are certain problems. Handling the material, civil engineer is necessary in a chemical plant, or in a power plant, or in a nuclear power plant. So we have to prepare our material, and we have to design our system in such a way that it becomes functional and its life is increasing. Apart from that, the productivity must be increasing and work efficiency with a reduced cost, economic improvement, and work environment. This improving work environment is a challenge to the world now. And the work environment, we talk about fire safety, we talk about quality of water that is being provided, we talk about uninterrupted power supply or energy over there. So these are certain, of course, we are doing some audits, energy audits, or water quality audit, or fire safety, or occupational health safety, which is audits we are doing. And I think that is only for auditing purpose. It is kept inside the files once audit is completed, and we do not adhere to environmental programs. So under such circumstances, when you go for automation, if you are having a software, or if you are having a system that there is a fire alarm immediately, and we can take precautionary measures in that respect so that we can prevent the fire hazards. Almost all buildings in the new building code of 2015, right? Fire safety is mandatory for constructing any building where for use of public. In engineering colleges, it is the hostels or the engineering classrooms or buildings or administrative blocks. It is mandatory. Whosoever may be the vendor, whosoever may be the contractor, it is mandatory. Then waste disposal is another part which has to be taken into consideration. And drinking water supply, how you can give a good quality of water which will not attract health hazards. That is of utmost importance for the human beings to work in a good environment. Equipments. I have already shown you what are the traditional equipments which are used in civil construction. Still we are using, but I have given 16 equipments which are used, and probably we have gone for automation. I am not talking about robotics over here. I am talking about what are the improvements recently over a period of 10 years or 15 years has been done. See, it is a tracked excavator and there is a JCB which is a backhoe. How it is working you can see from the pictures. And dragline excavators mostly used in collieries and for coal handling plants and others. Bulldozers, all of us we have seen how it works. And motor graders are available. You can see from the picture. Wheel tractor scrappers are also available for scrapping purposes. Especially the earthwork or preliminary work that has to be done before making a road or construction of a building or anything. And wheel trenches are nowadays available. So the long trenches with specified depth and all these things you can make. And tower cranes are used. Those who have visited Bombay, Mumbai, Delhi, or Calcutta, Madras, they might have seen tower cranes are mostly used in multi-story buildings. And smooth wheel compactors that I have shown you, it is used. Feller bunchers, a lot of road materials can be taken as a bunch and kept as material handling equipment. And this is a telehandler. You see, it is having a telescopic boom. The JCB is having a telescopic boom, maybe around 20 meters or 80 meters long, so that materials can be provided at a greater height, and that is adjustable. So it is a mechanical equipment. So these are the certain mechanical equipments for automating the construction industry that is going on. And asphalt pavers in the road where National Highway is now being constructed. Our Road Transport Minister, Mr. Nitin Gadkari, is telling that 100 kilometers per day I am making, right? So, and the hydraulic pile driving for making foundations and other things, that is also there. And pile boring machine. I am showing you these are used now, because from traditional way we are entering gradually to non-traditional way of doing things at a faster rate and with a good quality. Dump trucks are available, and a rod cutter that I have seen. I have seen in the villages or while even constructing my house that you will go for a Seni Martul, hammer and a chisel, right? And cut the rods or bend the rods and all these things. Now grinders are available which are quite portable, can be taken to the field and it cuts within less time so that quickly things can be done. And hydraulic drilling machines are available, deep holes and other things can be done. It can be transported from one place to another, it can run, and that's what I'm showing you. And the mixing plant, ready-made mobile mixing plants, I have shown you in the bottom picture. And the top picture you will see the mixing plant for making mortar, sand, chips and cement, water. After mixing it thoroughly, you can mix it. It is either done by, sometimes it was earlier done by hand, nowadays it is motorized. And ready-made mixing plants are there with huge capacity, and then dumping from one place to the other, mobile mixing plants are made. These are ready mixing plants, we call it in civil engineering. And digital construction laboratory you might have seen. I do not know. Digital construction laboratory is yet to come even in IITs. And engineering college, they don't have digital construction laboratory where a robot arm is there and robotics system is there, so that you can visualize things in a better way. And it is quite helpful for future engineers. So wheel loaders, and they're used in construction industry that I have shown you, crane and road rollers. These are conventional things. Finally, I have given you one Hadrian. This Hadrian is a fully automated machine which can erect the brick frame of a house in nearly 2 days. Imagine, we take minimum for single-story building with 3 to 4 rooms, minimum 30 days, or minimum, sometimes it is after putting the, going for making a plinth protection, going from foundation, then going for plinth protection, then going to the lintel level, from lintel level to the roof level. So we take considerable amount of time. This Hadrian is a robot which can work 24 hours a day, continuously. And lengthy process of building a home with human capabilities will be reduced to a few weeks. And this has been developed by Fast Brick Robotics. It is able to lay 1,000 bricks an hour with potential to raise 150 dwellings a year. Imagine this is the level of automation that we are thinking of. And from the 3D computer design of a house structure, the machine will be directed to load, cut, root, and place the brick in sequence using a 28-meter telescopic boom. 28 meters means around, it is 28 multiplied by 3.3 means around 90 feet or 100 feet. It is also versatile and work on a range of block sizes including multi-unit developments. Telescopic belt is also it handles 0 to 300 millimeter concrete slab and places material from sand to rock with 100 millimeter aggregate size. 100 millimeter aggregate size is a quite high, but it can handle. Telebuilt is the best solution for large construction, where long reach and high volume placing is required, such as dams, foundations and footings, bridge decks, tilt and outdoor slabs, batch force, etc. Of course, I am not interested about the design because it will be too boring for you. It has got 5 sections telescopic boom, base steel section of 4 telescopic high strength yet lightweight aluminum sections. Telescoping boom reduces problem with obstacles and saves labor and time. This is a versatile placement, clears obstacles and saves times and labor that I have already discussed. I have shown you how it works in a figure, and these are certain advantages which has already been discussed. Difficult physical work can be taken for automation, where automation and robotics, they do jobs much easily. It increases the efficiency. So countries such as Japan and Germany, they have improved their living standard and gross income that I was discussing with you. Gross domestic product becomes your gross income, and living standard has increased, per capita income has increased, and because of employing automation and robotics. Japan and Germany, they are far ahead than India. Okay? And work environment becomes quite conducive for the workers because they will be distanced from uncomfortable work positions. Certain examples. I have got 5 things which I discussed in the beginning while summarizing my talk. Autonomous machines, drones to survey working areas and employees. You see, surveying employees is another factor. That is a man management thing. And drones are there. The US CCTV cameras are now becoming mandatory for hotels and other places. Similarly, while doing the survey or managing the workforce and including officers in the site, drones are being placed. And robotics in concrete works also. IoT sensors to collect and process data. Internet of Things sensors. Sensor is a very vital part. And Internet of Things have to be used for processing data. Virtual reality during project planning and training, that I have already discussed. You have to simulate the system so that in advance you know what are the obstacles you are going to face. Autonomous machines, robotic technology solutions and sensors, forklifts, diggers, trucks, and other similar equipments can be managed without a driver in the cabin. Autonomous, like creating relevant path, providing capabilities, and programming movement of the machine itself. So remotely a worker can operate these things, and autonomous machines are being developed. And drones, I have already discussed. Robotics in concrete works, mixing of concrete, control systems, and lay these cement floors, remove the surface from the water, finishing, surface finishing, and ready mixed concrete products. They will take very less time if you are using robotics. Another area of concrete work is the benefits of automation is floor polishing. Programmable machines are being used to polish soft concrete in both commercial as well as residential structures. This can be programmed to pour and level concrete in the right portions while avoiding obstacles near the work zone. Demolition robots are also now available to bring down walls and dismantle concrete slabs very quickly. Today, while coming to the office near Bhubaneswar from my residence, yesterday I saw very two big columns for a flyover, and today I see that those are not existing. They have been dismantled very quickly using automated processes within a day. So, this is a safer working environment for employees if you adopt automation. IoT sensors to collect and process data. This real-time readings of location, temperature, pressure, and other environmental conditions. It will transmit the signals to you to trigger a specific action. For example, in welding or fabrication, to the machines, if you use these sensors will collect important environmental data from the field, and if you are using a robot type of welding machine, that I will show you. So, how much metal is being deposited for welding, whether heat affected zone is good or not, whether the quality of the weldment is excellent or not, so that there is no compromise on strength of the weldment, and these sensors will sense and give you. And when these sensors are used, they will trigger the action in the welding machine so that it will do the work. As a result, we get a good quality of work. Virtual reality during project planning. It is this environment, realistic environment, is to be simulated with scanned images. Series of scanned images are there. Builders can virtually crawl through pipes in the building to determine if they have enough room for repair and maintenance or not. Imagine. This is coming in a very big way. We have told all engineering colleges to go for virtual reality and augmented reality lab, so that our future engineers, because they have to live with this, the future skills that we are planning or giving training to faculty members as well as students is mostly on Internet of Things, artificial intelligence, machine learning, cyber security, virtual reality, data science, blockchain technology, robotics, and so on and so forth. Why? Because we are heading towards that. India is a largely populated country, so in order to improve, in order to go ahead with our projects and develop our infrastructures for better economic situation, we have to enter into this. Automated construction sector, precast concrete industry, automation is possible by using robots. Prefabrication of masonry and on-site masonry construction, and in timber construction also. In construction, nowadays for interior and exterior decoration, we are using timber or plywood or composite materials or even plastics. So, we have to think of robotics in this area. Apart from that, we cannot forget the traditional civil engineering materials, steel or aluminum, and so on and so forth. You see, I am now showing you some pictures, how robots are working for making a boundary wall, or making a wall after making the trench over here. 100% it is not possible. Cement, steel, glass, aluminum and wood work that you are doing, it is necessary that we should go for 100%, but at present we are not even achieved 50%. And partial automation robotics is also used in road construction, tunneling and earthworks. Regarding concrete precast component production, large degree of automation is utilized and necessary number of precast components can be produced as per buyer's demand. The automation precast components is very much beneficial because its quality will not change and waste generation will be very, very less. If waste generation is very less, then automatically you save good amount of program materials by proper planning and programming. Stationary mixer plants are not an exception, but substantial degree of automation and robotics are employed for quite a long time. On-site construction automation, several apparatus are used for different purposes in project site: concrete screeding, finishing, scrubbing, and cleaning. You see, automatic concrete screeding machine that I have shown you here, and this is surface finishing robot. Nicely it will surface. You need not to go there. You need not to stand there. Work from remotely located areas. And this is high-rise building automation. Cranes are available. Canopy is there. Climbing equipment and construction lift. So these are necessary for automation. And masonry prefabrication work play a very significant role. It raises the production of masonry blocks and decreases the manpower and labor costs. So the use of Hadrian that I have talked to you, 1000 bricks in an hour, 150 dwelling house that is used for making such type of skyscrapers. And partial automated masonry element fabrication that I have shown you here. Picture. I am showing only picture because all of you are totally tired and not interested to listen any mathematics or anything. And this is automated manufacture of brick wall masonry blocks. This is surveyed, put into computer-aided design, and the layout plan has been taken. Now people are not talking about plan and elevation. By going for a American paper, we were doing in drawing sheet, American sheets or German sheets. That was a 2D picture, either it was a prospective plan. And now people, when computers are available, 3D planning is possible, right? And 3D generation is also possible. You can cut a figure, go for a section, no question of full section or half section or quarter section view. And you can tilt the image in any way you like. That is the advantage the computer has given us. And this is the brick masonry robot. You can see that how very fast way it is positioning the bricks over here. This is a robot. Finally, it is seen that from the figures, the machine covers the entire structure and its cranes are partially automated, prefabricated parts of concrete panels, material storage management. In the construction site, if it is computerized, the erection of its structure is also partially automated so that you get a good quality of work, durable and at a lower cost. Timber construction, fabrication of wood frames. Robots are used. Wood processing has shifted from manually processing to complete processing utilize computer numerical controlled machines. CNC machines are available and which will produce prefabricated house components that I have told you. Tata Housing is doing that for timber as well as for aluminum sheets or corrugated sheets. that I have shown you in the beginning picture. Main purpose of showing you was that. And you see, multifunctional robotic wouldn't value it. Then, production of steel components, prefabricated steel components can be done by eliminating the process of manual welding or using bolts and nuts, and while erecting also very huge and heavy part. The utilization of steel in the house construction is very low, but there are factories which prefabricate component houses using automation and robotics. It is reported that such facility produces 5 to 10,000 houses per year, and it produces 120 meters square in just 2.5 minutes, and the house can be erected in 4 hours. That I have told you already. I have just given you one example, or it is a numerical set of examples which I have collected. A transformable automated welding robot in an integrated automated building construction, which led to decreased workforce up to approximately 70%. The problem in India is that whenever we go for automation or go for a change, we quickly do not accept it. And we go for a strike, either state one or Bharat one, because we will be losing our job. But without losing our job, how best we can give the best output, that is the question as far as India is concerned. You see, steel panel production facility, it is totally automated. I am just showing you figures. And welding robot in an integrated automated building construction site. Very small unit, portable, capable of welding, capable of sensing signals if you are using or interhooking the IoT type of things, Internet of Things. Those things can be controlled sitting somewhere else. So the conclusion is that the importance of implementing automation technology is the need of today's infrastructure project and construction firms in order to increase the productivity and good quality of work. Since India has second largest manpower in the world, automation is not replacement of the human power, but is an important supplement. I repeat, don't think that it is a replacement of human power, but it is a supplement that caters to the need of mega construction and fast track construction. These two words are very important, mega construction and fast track construction. The problems associated with the construction is decreasing quality of work, labor shortage, safety of labor, working condition of projects can be overcome by new innovative technologies such as automation, which has the potential to improve the quality, safety and productivity of the construction industry. Today it is evident that the level of automation in construction is very low in comparison with current technological advances. I am very clear. You can see, do you use virtual reality? Do you use drones for survey? Do you use drones for managing the on-site operations? Do you use such type of machineries and robots to do the work at a faster rate? Are we thinking of the safety of the labor? Are you thinking of the safety of the environment? No. So, we must make efforts to increase the automation level of this important sector, especially the construction sector. It is necessary that economic efforts from this private industry and government to provide funds and resources for research and development of robots technology. We see India is coming up through this technical education quality improvement programs. All technical institutions, faculty members are trained in future skills, and robotics as one part. Even if you develop a robotics laboratory, we are also funding, because I am heading this technology project in the state. That's why at the last I have added this word, but there are certain food for thought. The food for thought is how extensively we can use for increasing our efficiency in terms of artificial intelligence. That means a big amount of data you have to collect from the existing constructions and from the constructions which have been completed, so that we do not repeat this mistake in future. And 3D printing technology has to come in a big way to make a product within stipulated time or within a very less time, so that that product can be used in construction or in mechanical application or applications in chemical and Internet of Things. Extensive use of Internet of Things that is necessary. So data analysis, forecasting techniques, these are to be taken into consideration, including virtual reality and robotics. That's why I showed you one slide, that evolution of human and humanoid. So it is totally the limb that must function. If you are developing a robot, then automatically purpose for which the robot is to be developed, that has to be seen. Good amount of research is necessary. The kinematics of the problem must be understood properly, what you are going to do. Basically, robotics is nothing but it is a combination of mechanical, electrical, computer science, and electronics telecommunication technologies. If somebody thinks that I do not understand the mechanics, then he cannot make one robot. It is not possible for the purpose. And in a Cartesian coordinate system, if there are 6 degrees of freedom, how we can develop multi degrees of freedom? That is imagine. A robot, if it is hand, then it has got its flexion and extension. A human leg, flexion and extension, adduction and abduction. These are necessary. But when you talk about a neck of a human, it can rotate only 180 degrees, not to the back. Of course, magicians they do. So, taking into consideration the biomechanics, humanoid robots can be developed which will do better work. It may not be a replacement, total replacement for the construction industry, but some work can be done where there is a hazardous environment like handling of hazardous toxic substances, hazardous waste, and maybe nuclear waste, or preparing a sewage line which is perfect without hampering the health of the inhabitants or whosoever is there. So I think these things have to be taken into consideration by the budding engineers, those who are listening to me. I have not talked of anything technical. I have given you a story, what are the things in the past and still continuing, how we are developing, and what are the automation steps we have taken, and what are the future things, what we should do. So thank you very much for giving me a patient hearing. Sujit.
Sir, stop sharing. Stop sharing, sir.
How I will go? I will just escape.
No. Just okay.
I will close that one. Okay.
Thank you, sir. Very good presentation. Actually, I think as a mechanical engineer, that in the particular way that you have told, I think we are not able to means express that one also, and you have more knowledge in civil engineering also, sir. As this is the symbol of the experienced person, and you are now, sir. What is your age now, sir? Age?
64.
64, at the age of 64, and more enthusiasm you are, and you have given a nice topic, and I think all faculty members or that engineers that
I do not know how many people are attending, but I have not spoken anything technical. I have spoken based on my experience and what I see, what is going on throughout the world. So it may not be interesting for the person who are interested to know what are the.
No, sir. This is very much interesting. No, very much interesting, and all people should be aware of that automation in construction industry or robotics in construction industry. That is the most important part, sir. In nowadays, sir. Thank you,
You see,
sir.
simply when you request, I cannot deny you. So that's why for 2 days I was thinking what I will present and what I will speak. But still then I have done my job, and it is up to you to judge whether I have spoken correctly, rightly, and I have given the justice to my assignment or not. That's your job.
No, sir,
That's not
it is
mine.
excellent.
For
It
those who are
is, sir,
present
it
here.
is excellent.
How many
It is
how many
excellent.
people are attending this program?
Actually, I think 200 or 250 like that, sir.
I am not able to see any number over here.
No, no, sir.
It is a take-home sponsor program, our sponsor program.
Yes, sir. And like previous program, they are joining through YouTube link, sir. That I have sent in the last program. I will send that YouTube link, and your video has stored, and you can see later on also. So all the participant has joined through YouTube link.
Great, great,
YouTube
great,
links.
great,
YouTube
great.
links, sir. YouTube links, sir. So in future also participants or we also see that video. So it is stored on
I know
uploaded in
that.
the
I am
uploaded
a
in the
small
website
man.
also.
Thanks everybody. Thanks to all the faculty members for giving me this opportunity. And I have tried my level best. I
Thank you,
don't
sir.
I don't remember studies anymore.
No, sir, very good thing. Thank you, sir. Thank you joining us at ARC 2021, organizing jointly by Civil and Production Engineering.
Okay. Thank you very
Okay,
much.
sir. Thank you, sir.
I'll be available on 21st.
At IIT, sir.
Yeah.
Okay, okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
So I can call it a day?
Yes, sir. Yes, sir. Yes, sir.
Thank you. Living.
Thank you, sir. Living, sir. Yes.
Okay. Thank you.